Okay, in these sample problems we're looking at exponential growth and decay. And in this first problem we have y equals 34 times 4 to the x, and we're asked what is the growth factor. The growth factor is 4 because it's the number with the exponent on it, and we know that it's a growth factor because it is greater than 1. So the answer to this would be 4. In the next problem, it asks us what is the initial amount, y equals 15 times 3 to the x. Our initial amount is what we multiply the power by, so it would be 15. In the next problem, we have y equals 17 times 0.2 raised to the x. It asks for the decay factor. We know that this is the decay factor because it's the base for our exponent of x. And we know it's a decay factor because it is less than 1. And our answer is 0.2. So we know that our factors will be the bases raised to the exponent of x. And if it's greater than 1, it will be a growth factor. And if it is less than 1, it will be a decay factor. And our initial amount will be the number that we're multiplying by. Okay, so we have a population of fish in a lake decreasing 6% annually, and they want to know the decay factor. So our decay factor is equal to 1 minus our percentage, but we have to write the percentage as a number. So it would be 1 minus 0.06 because 6% means 6 out of 100, and if you divide that you get 0.06. When we subtract 0.06 from 1 we get 0.94. So that would be our decay factor. If the population had been increasing, to find the growth factor instead of subtracting right here, we would have done exactly the same steps, but we would have added, and our growth factor would have been 1.06. Okay, here's a problem with compound interest, which is actually just an exponential growth. Your parents invest $20,000 in an account paying 5% interest compounded annually. What will the balance be after 10 years? So $20,000 is the principal, that's how much we start with. R is our interest rate, and it's 5%, which is 0.05 as a number. Annually means that we're going to compound it once a year, and we want to know the balance after 10 years, so that's our T. This is our formula for compound interest, and you need to keep that handy. And so substituting in 20,000 for the principal, 0.05 for the interest rate, N for 1 for the compounding, and then 1 times 10 for the time period. We substitute that in and plug it into the calculator, and we get the answer of $32,577.89. And you can check that arithmetic on the calculator for yourself to make sure that it's right. Okay, in this problem, we have g to the x equals 14 times 2 to the x, and we just want to identify some of these terms. Remember, the 14 will be our initial amount, and the 2, which is the base on our exponent of x, since that's greater than 1, 2 is greater than 1, that means this is our growth factor. On the next example, y equals 5 times 0.5x. 5 will be our initial amount. And 0.5, since 0.5 is less than 1, that would be our decay factor. So in the problem number 6, whatever it is we're looking at is getting bigger, it's growing. And in problem number 7, whatever we're looking at is decaying or decreasing.